Hello class, how are you doing? In this video, we're going to study conic sections. It's a very important topics in geometry, has many applications in real life. And many of you have been exposed to it in college algebra, pre-calculus. It's not a part of our curriculum in calculus 2, but I'm going to cover it, at least some of it, to have some idea, because later you're going to need it in Cal 3 and also you need it in this course in Cal 2. Prior to my lecture, I want you to listen to this video.
In this module, you will learn about conic sections. When a straight line intersects a vertical line at a fixed point and rotates about that fixed point, the surface obtained is called a double right circular cone. A double right circular cone consists of two cones joined at a fixed point called the vertex. The line that rotates about the vertex is called the generator, and the line that remains fixed is called the axis. A right circular cone has a circular base, and its axis is always perpendicular line from the center of the base to the vertex. The perimeter of the base is called the directrix. The lateral surface of a right circular cone is called a nap. A double right circular cone has two naps. The nap above the vertex is called the upper nap, and that below the vertex is called the lower nap. Also, the angle between the generator and the axis is called the vertex angle. Conic sections. If a plane intersects a double right circular cone, we get two-dimensional curves of different types. These curves are called conic sections. Depending on the angle made by the plane with the vertical axis of the cone, the plane can cut the cone in three different ways. Ellipse. When the plane intersects the double right circular cone in such a way that the angle between the plane and the axis is greater than the vertex angle, we get a closed curve called an ellipse. When the plane is perpendicular to the axis, the ellipse becomes a circle. Thus, a circle is a special type of ellipse. Parabola. When the angle made by the plane to the vertical axis is exactly equal to the vertex angle, we get an open curve called a parabola at the intersecting surface of the cone. Hyperbola. The plane intersects only one nap of the double right circular cone as long as the angle between the plane and the vertical axis is greater than or equal to the vertex angle. However, if the plane intersects the vertical axis at an angle smaller than the vertex angle, the plane intersects both the naps of the cone to form an open curve called a hyperbola, which has two disjoint curves. Degenerate conics. If the plane intersects the double right circular cone at its vertex, the ellipse becomes a point, the parabola becomes a line, and the hyperbola becomes two intersecting lines. The figures so obtained are called degenerate conics. In this module, you have learned that when a plane intersects a double right circular cone, two-dimensional curves called conic sections are formed. There are three types of conic sections: ellipse, parabola, and hyperbola. When the double right circular cone is cut by the plane so that the angle between the plane and the axis is greater than the vertex angle, the ellipse is obtained. When the plane is perpendicular to the axis, the ellipse changes into a circle. If a double right circular cone is cut by a plane so that the angle between the plane and the axis is equal to the vertex angle, the parabola is formed. If a double right circular cone is cut by a plane so that the angle between the plane and the axis is less than the vertex angle, the hyperbola is formed. If a plane intersects the double right circular cone at its vertex, the figures formed are called.
Okay. Then we study, you watch that video, and from now I'm going to go ahead and teach you what is the relationship between the points on the graph and what is the equation of those conic sections. Okay, in here, I'm gonna go and ask this graphing calculator to give me a line, just a line, and that's the line. And as you saw in the video, I call this line the line of direction, or I call it directrix. I'm gonna select a point outside this line. You can put it on up or top, but I have more space on the top. I put them on the top. Then I will ask to give me a points on the line, but I really need about 1,000,000 points in here. 1,000,000. But later on, what I do, I'm gonna use the dynamic version of the calculator and I move that point. Pretty much that take care of all the points on that line. But what we're gonna do to all those points on that line, I'm gonna take all those points on the line and I'm gonna connect it to that point. Then I'm gonna ask, where is the midpoint of this line? That's called perpendicular bisector. Then after that, I'm gonna ask to give me a perpendicular line to this line passes through that point. I'm gonna do the same thing to every other point. I'm gonna connect it to the point C, which is outside my line, and I'm gonna draw a perpendicular bisector. Then from the points on the line, I'm gonna do a what? A perpendicular line passes through and is going to have 2 points created. This intersection and this intersection. Okay, then I'm gonna ask, do it for that point, do it for that point, do it for that point. These are you gonna do it for every one of those points. Then you're gonna ask the calculator, as you move from this point to that point, place a dot on the previous location. Place a dot means give it a trace. Leave a trace. Okay, therefore I'm gonna move that point and these are my trace. And the trace of all of them produce a parabola. It was one of the conic section, and parabola was produced when the angle between the plane and the vertical angle was the same. Then I want to know what is the relationship between this point, what is the x value of it, what is the y value of it, where is the x value, where is the y value. I'm going to assume right now that I'm going to move that point right here to my right side, that it make it a little bit easier for me to move. And I'm going to ask the graphing calculator, give me a line segment from this point to that point, which I find is trace. Then I'm going to ask the calculator, how much is that distance? Give me that distance, 5.35. Therefore, as I move, that distance change. And this is the smallest distance you get. After it get larger and larger and larger and larger. The line passes through the bottom of the parabola, which we call it vertex, and the point we picked above the line, that line called the line of the symmetry. Therefore, a parabola has a vertex point, which is unique. There is only one vertex. The point outside here, and also you have a directrix line. I'm going to move that point D, and I'm going to say, okay, directrix has something to do with my parabola. Then give me a line segment from here to point D, and that's called line segment of D. And I said, what is that distance? Oh, what is that distance? 4.99. What is that distance? Are you telling me that distance and that distance are the same? Therefore, any points on the parabola have same distance to this point and the same distance to this line. Let me see what happened to the other point. Oh, no matter where I move it, that distance stay the same. Then let's talk about the parabola. Parabola is a set of points. These are all points, and all together called a set. That every point have same distance to a point and a line. That point called a focal point. If you look at your satellite dish, in satellite dish, they call this one your LNB. What does it mean? The signal come from the space to this point and deflect it to that point. See, you hit the sun ray here, and from here you get deflected to that one. From here I can connect it with a wire to my water heater. Or the signal comes here. The signal comes here from the space, like AT&T, like Dish Network. The signal get deflected to that point. From here, with a wire, we bring it to the receiver, and receiver change the signal to pictures and sound and give it to you in the TV. Then, from today, you have to know that parabola is a set of points. All points have same distance to a point, which call it a focal point, and a line which called that line a directrix. Let's find out what is the equation of that parabola. And that's what we're going to talk right now. Therefore, I'm going to turn my video and I'm going to go right here and I'm going to say, let's find the equation. Well, I'm going to put my x-axis here and my y-axis here. For my convenience, I'm going to put the vertex here. I put my focal points here, and I put the line of directrix here. And we did say that distance and that distance are the same. Therefore, I'm going to assume that distance is a p. Because I am at the origin, the x is 0, the y is a p. That distance is a p, but because it's below x-axis, this is the line of y equal to negative p. And we said the parabola is a whole bunch of points that have same distance to a point and a line. You see, I did not graph my parabola correctly because these two are not the same. If you really want to do that, you got to make your parabola what? Your parabola should have become skinnier. Then when you pick a point right here, that one and that one become the same. Therefore, I want you to assume right now, just for the sake of it, that these distances are the same. Therefore, I'm going to do it again. That's x-axis. That's the line of y equal to negative p. And this is my vertex. And I need a point here. Therefore, I need that distance right here. That's good. That distance and that distance should be the same. Therefore, my parabola must pass through that point. You see how nice it became now? Then I said that distance is a p, this is 0 and a p. And this is the line of y equal to negative p. But that point could be any point on the parabola. Therefore, that distance should become exactly equal to that distance. I know what that distance is. The distance between 2 points is x2 minus x1 squared plus y2 minus a y1 squared. At that point, the x is the same as that x for that point. But the y is a negative p. Therefore, that distance is x minus x0, because there is no change in x, plus y minus negative p squared. These two distances must be the same. Then let's do those distances. Therefore, I'm going to make this one equal to x squared plus y minus a p squared. Both of them have radicals. Therefore, I'm going to square both sides. And x minus x becomes 0. Then I have this equal to that. Then let's do it. You have y plus p squared equal to x squared plus y minus p squared. And when I expand this one, it becomes y squared plus 2yp plus p squared equal to x squared plus y squared minus 2yp plus p squared. That is gone. This is gone. That negative 2 come here, become 4. Equal to 4py equal to x squared. And what is y? 1 over 4px squared. And what is that p? Is a distance from a vertex to the focal point. If you remember in college algebra, we called the whole thing a. Therefore, really that's equal to y equal to ax squared. And in this case, really your a is 1 over 4p. Okay, then I'm going to ask you a favor. There is a parabola. The vertex is at 0, 0. The distance to the focal point is p. And instead of that p, I'm going to place 3. Write equation of a parabola is equal to 1 over 12x squared. But let me ask you a favor. If I take as a p right here, you know on the parabola I'm going to have same point here and here. I'm talking about that one right here. Therefore, this distance is 0p. This one is x and a p, and this distance is x, negative x, and a p. Oh, I know what this one is. This is nothing except 2x. Therefore, that distance is nothing except 2x. And let me see how can I find that distance. I'm going to write the square root of x minus x squared, which is become 2x minus negative x minus negative x minus negative x squared plus p minus a p. And see, that's become x squared. And then when I square that one, no, I did something wrong right here. This distance is p and x. That distance is negative p and x. Okay, I know what I'm going to do. I know equation of a parabola is y equal to 1 over p x squared. This is my point because it passes through the what? The focal point. And the distance right here is a p. Therefore, I'm going to go replace the y by a p and x by the x. That's x squared. Then I'm going to say 4p squared equal to x squared. My x is 2p. I find that distance. That distance has to be twice as much as that distance to have a perfect parabola. Therefore, if I ask you, this one is a parabola and the p is 1. If you really want to graph that parabola perfectly, this distance must be twice as much. Well, if this is 1, that's once, that's another one. You go the same distance to other side, then that's the correct parabola. You know, sometime in calculus, we just put y equal to x squared. I said, this is a graph of a parabola. That's not a right way to do it. They call this distance from here to here Lattice Rectum. And your Lattice Rectum, your distance, if I call it A, is 4p. That Lattice Rectum, I call it A, 4p, because this is 2, that's the 4p. Therefore, you gotta know, whenever you graph a parabola, what is your P? What is the length of a lattice rectum to give you the width of a parabola? What is the vertex? And pretty much that's the equation of a parabola. But somebody said, what happened if the vertex move at h and a k? I said, well, your y equal to 1 over 4px squared, it becomes y minus a k equal to 1 over 4p x minus h squared. Somebody said, what happened if the parabola is to the right or to the left? I said, then it becomes x equal to 1 over p y squared. And the center, it could become x minus a k equal to 1 over 4p y minus, oh no, that's a h. Y minus a k squared. Therefore, this is for any parabola that faces up and down. This is for, right and left. And this one is for any parabola to the up or down. Did you see that 4p? That 4p is the length of your lattice rectum. What is a lattice rectum? Is a line segment that passes through the what? Passes through the focal point. It is perpendicular to the axis of symmetry, and the length of it is twice as much as from the vertex to the focal point. Therefore, if this is P, this side is 2P, and this side is 2P, then you have a perfect graph. Then you can see your directories have to be right here. Therefore, the distance, if you know that one, pretty much you know that one. And that's the graph of how you write equation of the parabola. I hope you enjoy it.